Alrighty? So here we go. Take a look at problem number 31. This is one of the handy dandy mixture problems that you did in first year algebra. Remember those? 31, where you've got some 10% solution and some 20% solution, and you're going to mix them together and get an 18% solution. Remember those? Now, you can draw pictures like they did there in the book of buckets or pails or barrels or boxes, whatever you want. Some people set up charts, tables, where you kind of organize everything. My personal preference is, because I'm a little on the lazy side, ultimately I want an equation to solve to get the answer. And the format of that equation will always be amount times percent plus amount times percent equals amount times percent. So in a mixture problem, you're mixing two things together or more. It could be more than two. Usually it's two. You're mixing two things together and coming up with a final product. In these problems, the percentages are always known. So read problem number 31. What am I mixing together? A 10% and a 45%. So this is a 10%, this is a 45%, and I'm mixing them together and going to end up with a what? Was it 25? Yep, 25%. Okay. Now, in these problems, one of the amounts will be known, and then you'll have to name the other two with variables. All right, so which one do I know? I know the final product is going to be 100. So I know that these two have to add up to 100, right? Now I have no idea what this one is, so I'm just going to call it X. I have no idea. But if I call that one X, what will this one be?
100 minus X.
Very good, Brenton. 100 minus X. Now, for some reason, that blows some of our minds. But think about it. If this hand and this hand have to add up to 100, and I know I have 30 in this hand, you would tell me I had how much over here?
70.
And how did you get 70? 100 minus 30. So if this is X, this is going to be 100 minus X, right? Every time. Every time. Okay. So now I got my equation. I'm ready to go. So I have 0.1x plus 45 minus 0.45x, just doing my distributive, equals 25. So negative 0.35x equals negative 20. And the answer is, I got about 57.14 gallons. Yep. What do you think? Is that what you got? Okay, I need someone to like nod or something. Good? Okay, well let's not let Mrs. Ford do all the work. Although I am the one getting paid, that's true. Not much, but I am getting paid. It's helpful if you work along with me. All right, is that all right? Mixture problem. All right, let's look at another one on here. How about number 30? That was 31. How about number 30? This problem set is all about random problem solving, okay? So 30 has nothing to do with 31. They're totally different. What's your strategy for number 30? You've done this before too, back in Algebra 1.
The original minus the percent, I don't know what it's called, but it's like the original minus the change, yeah.
Well, it's the change, which is the new minus the original. So it's the change divided by
The original.
exactly. If you want to find percent increase or decrease, you're going to take the change and divide it by the original. That's what you're going to do every time. So for us, number 30 would be 26, oh wait, let's see. It would be 3989,000 minus 26,650,000 divided by 26,650,000. Does that look okay to everybody? Yep. So we type it in to our trusty calculators, hopefully getting all the zeros in there. I don't know if I got all the zeros. Check me. I got about 16.28%. But I may have missed a zero somewhere. What do you think? Is that okay? Good? Everybody's good. Okay, next, let's look at problem number 26. I'm just skipping around. There's a few I want to do, and then I'll let you just pick some, all right? But let's look at number 26 because it uses another idea from first year algebra. It's been a long time ago for you, first year algebra. Anybody have an idea? Griffin, you with me, buddy?
Yep.
Okay. Number 26, who has an idea? Anybody?
I gotta read.
Okay, that'd be a good idea, Frank. Start by reading. Brenton has a very good plan. He says, I'm going to read the problem first. Good, good, good. Jeff, what are you doing, sunshine? Good. Who's got an idea? Make an equation, yep. What would that equation look like?
So if it was 2 hours more, then there's 2h plus.
Okay, wait a minute. Yes, so you're getting some foundational ideas there. You're going to let H be something.
H be hours.
Oh, what hours, though? The hours where? On local or on the interstate? You want this to be hours on the interstate. Okay, then what will be the hours on the local? No, not a new variable. I don't want a new variable.
2 plus 2h.
2h?
Wait, no, it's the opposite.
2 plus
2 plus h?
It's 2 hours more.
Wait, no, maybe on the first one.
The
It
first
means-
one would be 2 plus h.
This one's 2 plus h?
Yes.
And this one is h? So you're letting h be the hours on the local streets or roads, whatever. And then we're 2 hours more on the interstate. Is that what it says? Okay. All right. That's a good way to start. Now what else? What? So the total distance is 560 miles. And that distance is broken up into 2 pieces. it's the distance on the local plus the distance on the highway. Would you agree with that? Now, how do you find distance? Not the distance formula, not the distance between 2 points, you know, the square root thing, not that. How do you find distance going down the highway? Rate times time, right? You're going 18 miles an hour for 2 hours, you would have gone 36 miles. Rate times time. So, what is the rate on the local highway? Speed.
45.
45. You told me the time was h. Plus, what is the rate on the highway? 55. And you told me the time was h plus 2? There's your equation. The distance on the local roads, which is rate times time, plus the distance on the highway, rate times time, equals the total distance, which is 560. I got 4.5 hours, but I did that in my head, so who knows? Is that right? You okay? All right, I'm gonna do just a couple more and then I'll let you start picking them. Take a look at number 19. I just think when you say 19, you sound smart. Griffin, read 19 out loud.
The sphere is contained in the cube, tangent to all 6 faces. Find the surface area of the cube as a function of the radius of the sphere.
Whoa, that sounds really hard, but it's not. It's not. Let's draw a picture of it. I like to draw pictures of stuff.
It's hard.
Here's my cube. I'm looking at my cube from the front. And inside the cube is a ball that just fits. It just fits perfectly in there. That's what it means to be tangent to all the faces. It means the ball just fits perfectly. It won't wiggle around. It's snug in the cube. And my job is to find the surface area of the cube. Now, what do I know about surface area? What does that mean? What is surface area? Like if I were looking at this box right here, how would I find the surface area of it?
Add up all the
Add up the areas of all the sides, right? All the sides, including the top and the bottom. So a cube has how many sides? 6. And since it's a cube, they're all equal. They're all squares, right? So what would be the area of this side of the cube? S squared, and you said there's 6 of those. So the surface area of the cube is 6s squared. Does that make sense to you? That's very simple, right?
That's it.
Well, that's it, except this is the surface area in terms of the sides of the box. What am I supposed to be doing? Finding the surface area in terms of the radius of the sphere. So this is one of those things that happens a lot in first year calculus. You have to, or first semester calculus, I should say, you have to rename or rewrite the exact same equation. This is a correct equation. It is perfect. The problem is, it's in terms of S, and I need it to be in terms of R. I need R's here, not S's. So you need to look at your picture, and you need to find a substitution. What could I put in place of the S? 2R. Doesn't S equal 2R?
Yeah.
So I can take this S and replace it with 2R. And now my equation is in terms of R. It's exactly the same equation, but now it has the right variable that I need. What?
Wouldn't it be 12?
No, because
You're squaring it. Remember, we're squaring the whole quantity. Common mistake. Be careful about that. We're squaring the whole thing. I'm going to do one more, and then I'm going to just ask you, and we'll just spend the rest of the period doing problems, whatever you want to do. Number 9. You're to write an expression that represents the sale price of an item marked X dollars if 40% is discounted. So you walk into the store, you see something you want to buy, and it says 40% off. So what would be an expression for the cost of that item, Brenton?
would it be X minus 0.4?
Yeah. Now, here's what I want to talk about, Brenton, because this is okay, but that actually simplifies.
Okay.
And I want you to do it in simplified form. Okay? So this is 1x, right? Minus the discounted, which is 0.4x, that's right. What would that equal? What? 0.6x.
So we just put 0.6.
Yes. So the answer, I would just put 0.6x. Now, here's what I want you to think about. This is going to make your life so much easier when we get to some other chapter, like chapter 9 or something. Listen to this. Your job was to tell me the actual price that I was going to pay when I went in there. When Brenton did 40% of X, he wasn't talking about what I would actually pay. He was talking about what I would not pay, right? So instead of using the 40, let's just bag that all together, not mess with the 40, and say, look, if I'm not paying 40%, then I am paying 60%. So I'm not going to mess around with that subtraction. If I go into the store and something is 20% off, I am not going to multiply by 0.2 and subtract. I'm not going to do that. If it's 20% off, then what am I paying? 80%. So I'm just going to take whatever the marked price is and multiply it by 0.8 every time. So instead of doing that subtraction, don't make it a two-step problem. It's going to be hard in the future. It works, it's fine, but it's going to be hard. Make it a one-step problem. If you're not paying 8%, then you are paying 92%. Make sense? Okay. All right. So we got a few minutes. We got lots of time. We can do 10 more problems. What do you want to do? Want to start at the beginning and work through? Want to start at the end and work up? Want to start skipping around? I don't care. This is probably the last day we'll spend on this assignment. 15. Absolutely. The height of a right circular cylinder. This is 15. The height of a right circular cylinder. So I'm going to draw that. Here's my right circular cylinder. And here's my height. Equals its diameter. So here's the diameter. and it says height and diameter are the same. Where's the question? Okay. Write the volume of the cylinder. Okay, well, first of all, what is the formula for the volume of a cylinder? Pi r squared h. That's right. Pi r squared h. Now, kids, there is nothing wrong with that formula. You're going to find that in every geometry book you look in. But for this problem, it says we don't want r's and h's. We are to write this equation and only use radius as our variable. We're writing this as a function of radius. That means in terms of r only. So you gotta get rid of the h. Well, how are you gonna get rid of the h?
Well, H equals D.
H equals d. And what do we know about d? What's diameter?
2r.
2r. So we'll just take out that h right there and plug in 2r. So our new formula is 2r cubed pi, or 2 pi r cubed. Now, this formula and this formula are the same for this problem, for this particular problem. Our direction said we don't want any h's, so we had to write it this way. Because that's what our direction said. Lift your hand up, sweetie. Rachel,
No, it's not.
do you want to put it up?
Nope.
Okay.
So you do the next problem, 16.
16. One leg of a right triangle is twice as long as the other. Okay, so one leg of a right triangle, here's my right triangle. One leg is twice as long as the other. Does that make sense to you? This is 16. Write the length of the hypotenuse as a function of the length of the shorter leg. Well, is x the shorter leg? All right, so here we go. I'm going to do my hypotenuse. H squared equals x squared plus 2x squared. Would you agree with that? Handy dandy Pythagorean Theorem. So h squared equals x squared plus 4x squared. H squared equals 5x squared. So what does h equal? H equals, watch it, root 5x. And make sure that x is not under the radical sign. And many times, Griffin, I will plus or minus that and scream and yell if you don't, but not this time. Because what does h represent? Hypotenuse. Will the hypotenuse be negative? No. So in this case, I'm not interested in the negative.
33.
33.
Isn't that what we did yesterday? No, we just had this one.
Well, 33 is a box problem.
Okay.
Yep, 33 is a box problem. So we ought to be able to set this one up real quick and get her done here. Remember, on the box problem, it's question number 1 on your test, and it has 3 parts. The first part is write the equation for the volume of the box. So what will the volume of this box be? This is question A, 33A. Write the volume of the box. What will it be? 10 minus 2x. This is number 33. So 10 minus 2x, 18 minus 2x, and x. Now I did this problem with another class this morning, and somebody said, okay, wait a minute, what's that x?
Oh, that's not height.
That's the height. You gotta have length, width, and height if you're doing volume. 2 of them aren't gonna be enough. You need 3. All right, there it is. Question 2. Find the domain. That means x is going to be where? Between what and what?
0.
Always 0. X will never be negative in this problem, right? Always 0. And in this case, up to 5. For this dimension, it could be 9, but could it be 9 for this dimension? No, you gotta go with the small one. Remember, your paper's only 10 wide. You can't take 9 off each side of 10. And then the third question this time is, and the question sometimes changes, it says, find the dimensions of the cutout squares. So in other words, when you graph that thing on your calculator, and you're going to use x min as 0, x max as 5, what's y min going to be? This is y, volume can't be negative, so you're going to use y min as 0, and then y max, you're just going to guess, right? And you're going to keep changing it until you see that shape. Now, when you finally see that shape, and you do second count, max, left bound, right bound, all that stuff, you're going to get an ordered pair. What will this part of the ordered pair represent? X. In this case, that will be the answer, right? Because it says, how big are the cutout squares? What will this part of the answer represent? The volume. And that would be the answer if the question said, what is the volume of the biggest box you can make?
It does say maximum volume.
No, it says, determine the dimensions of the cutout squares that will produce the maximum volume.
So that's x.
That's x. You would be looking, in this case, your answer would be the x coordinate of your maximum.
How did you get 5 right there?
Somebody tell her, how did you get 5 right here? What's our logic? The shortest side is 10. I'm going to cut something from both sides so that it can't be more than 5. Clark, sit down, please. Okay, do I see you tomorrow? I don't, do I? All right, then I will see you on Thursday. Have a good day. Good day tomorrow. No,
This board.
Yeah.
So you have every Sunday open?
yeah, unless there's like the next one, we won't have a fall break. We will not have one over fall break.
Yeah.
The first
And
day.
then also, you do tutoring, right?
October 18th. I'm here to help my own students before and after school.
Is that it then?
What?
Is that all you tutor then? You only tutor before and after school?
I'm not sure what you mean. I will help you before and after school. When did you want to be helped?
No, I was just like asking, because someone said they were tutored by you.
Yeah, if they're not my students.
Really?
Yeah,
Yeah,
so-
so Maggie was saying that.
Yeah, Maggie, I've been helping Maggie, but she's
Yeah.
not my student. You are free to come to open gym. You can
Yeah.
come in before school. You can come in after school's a little harder some days.
Yeah, I can't after
but-
school.
Okay, then try before school.
Okay.
All right. Try some of these problems and then come in and let's look at some you can't get.
Okay, so then.